Citric acid cycle, part 2. All right, we've gone through this acetyl-CoA in the mitochondrial matrix being broken down, having its acetyl group, adding this 2-carbon acetyl group, this whole thing is our acetyl-CoA, to oxaloacetate, producing this citrate, this citric acid, all right? And this is our step 1. So let's keep going here. Now, for each acetyl group entering the cycle, let's give ourselves just like, this is kind of like, okay. All right, for each acetyl group, three NAD plus are reduced. Right? It wants that electron. It wants to be reduced so it can become whole again. Are reduced to NADH. All right, and how many acetyl groups are coming in? Well, one pyruvate is one acetyl group, and we have 2 pyruvates, so this is where 6 NADs are going to come from. So I want to know where the other 2 are going to come from. Ah, 2 are from oxidative phosphorylation. There it is. I'm sorry, pyruvate oxidation. That makes perfect sense because this is kind of tying them together. Jesus Christ, there's so much here. That's what we kind of have to keep in mind this whole time. All right, for each acetyl group, 3 NAD plus are reduced to NADH, okay? So, maybe we could do a little recap here. Pyruvate. Pyruvate. Well, no, not exactly. Well, in that, I think 2 NADH has come out of that, right? And that's going to go to acetyl-CoA. And the acetyl-CoA is going to reduce go to 3 NADH. Three NADH. Call it out. All right. Now, when our pyruvate went to acetyl-CoA, we're getting 2 NADHs out of this. All right. So we could say NADH and one here, NADH. Okay? 1, 2, 3, 4, 5, 6, 7, 8. There's our 8 NADH. Okay? I think we're getting 2 CO2s from here, but that's where our NADH is coming from. We're getting 2 CO2s. And I'll put a CO2. Where else are we getting CO2 from? Two different carbons leaving the completely oxidized form of CO2. I think happens somewhere in here. We'll get to that. Let's keep going. And that's steps 3, 4, and 8. Okay? Step 3, step 4, step 8 for these NADHs. Okay? This happens in step 3, step 4, and step 8. Okay? In the Krebs cycle. 3, 4, and 8. Cool. In step 6, I know we're kind of skipping around here a little bit. So this is kind of like our, yes. In step 6, electrons are transferred. In step 6, electrons are transferred to something called FAD, which becomes something called FADH2. And you can see that up here. FADH2. What is FADH2? Let's go into that. not sure it really says. All right, step 5, we kind of skipped one here. In step 5, this GTP molecule is formed. GTP formed by something called substrate level phosphorylation, or I'm going to say S level phosphorylation. All right, maybe we can get a definition on substrate level phosphorylation. Yes, we can. This mode of ATP synthesis basically just means an enzyme is transferring a phosphate group, an enzyme, and this basically means an enzyme transfers a phosphate group transfers a phosphate group from a substrate molecule to ADP. To ADP. There's a D there. Okay. Now, this GTP, this is important. I'm going to tell you why. This GTP can make ATP. All right? GTP can make ATP. In fact, this is the only ATP generated. The only one generated in the citric acid cycle, okay? There you go. And it's multiplied by 2. Why? Because you have 2 pyruvates, 2 acetyl-CoAs. All right? That's where your ATP is coming from. Step 5. And 2 different carbons. 2 CO2s are coming out there. 3 and 4. Step 1. Step 3 and 4. CO2 is lost, and 2 of them, which would be 4, and there's your 6, right? Steps 3 and 4. In steps 3 and 4, steps 3 and 4, CO2 is produced. All right, 1 and 3 and 1 and 4. 1 per. All right, that's where our 2 CO2s are coming from. Doubling that to 4, 5, and 6. That's our 6 CO2. Our NADHs, we got 6 of them right here, 7 and 8. There's our 8 NADHs. This is our 1 ATP, doubling that to make 2. And this is our step 6 is our FADH. So we can even say this, right? FADH is step 6. ATP comes from step 5. Our NADHs, what step is this? Well, this acetyl-CoA part in our initial CO2 really is pyruvative oxidation. Our CO2 comes from pyruvative oxidation and partly comes from 3, 4, and PI. So 3, 4, but also from our PO. All right, that's why it's not as simple. NADH, you can see, is all kind of right here. Okay, let's look at a couple more things about.
This is Webflow. Meet the design tool from the
ground up. Let's go back to Bozeman here.
ATP to ATP, but we're all of carbon cycle. We called it, off in the form of molecule complex. And basically what it's going to do is it's going to convert that 3-carbon molecule into acetyl-CoA. This is coenzyme A. So basically now we have a 2-carbon molecule that is going to go into the Krebs cycle. Now, since we're going from a 3-carbon pyruvate to a 2-carbon acetyl-CoA, we're giving off carbon. And that carbon is going to be given off in the form of carbon dioxide. So when you breathe out, a third of that carbon coming out of you is going to come right here from this complex inside the matrix, we call this. I should have said that before. This is the matrix on the inside of the mitochondria. Okay, let's keep watching acetyl-CoA. So it's a 2-carbon molecule. Where does it go next? It goes to the Krebs cycle. And so in the Krebs cycle, we're going to break it down further, and we're going to get rid of these 2 carbons in acetyl-CoA, and we're going to give those off as carbon dioxide. So we're getting rid of carbon dioxide. What else are we producing in the Krebs cycle? You can see here that we're producing a little bit of ATP, 2 ATP, but we're also adding energy, again, to NAD, and we're adding energy to its friend, we'll call this fad. And so what a NAD and fad have, they have these high energy electrons, and they're going to carry those electrons to the third step, which is the electron transport chain. Okay, let's get to the electron transport chain then.
What we're leaving from the citric acid cycle is all of this NADH, all of this FADH. Well, there's two of them. CO2 has been, and there's a little bit of ATP. So it's this NADH and this FADH, which is really going to flow into our next section here, which is going to be a doozy, and we'll get to that in a little bit. So, recap, because repetition leads to memory. I eat some sugar. I have glucose going down into me, okay? We're going to do glycolysis